Hello, this is another video in the Random Linux Stuff playlist. Now this is a long shot. I don't know about your concentration span, but mine is less than 10 minutes. So I'll do my best to keep it within those 10 minutes, if only for myself. Unfortunately, one of my hobbies is storage, so I could go on for hours about this, but as promised, I will keep it short, and I hope you like it. When we think of storage nowadays, the following three solutions immediately pop up: block level, file level, and object-based storage. To my mind, getting to grips with these storage solutions can best be done by simply looking at it from a client perspective. So what does the client see? What's the client's level of control? And what does the client need? And things like that. Now let's start with block storage. Block level storage simply means that whatever is written to the storage device will be in blocks of a predefined size. The client will see a device in the form of a disk drive. This drive may be a device that is local to the client, so an actual physical or virtual disk, and it may be offered by a storage controller across some network. Whether it's local or not, it doesn't really matter to the client. The client operating system is responsible for partitioning the device or not partitioning the device, create a file system on the device or not create a file system on the device. In other words, it is in full control of the device. Now, just to be exact, if the device is really local to the client, it is referred to as DAS, or Direct Attached Storage. If the device is presented via a network using protocols like Fibre Channel, iSCSI, or NVMe, it's referred to as SAN, or a Storage Area Network. Now this all looks pretty nice. The client is in full control, so sharing the device with other clients is hardly ever an option. Also, what if the device fails? Usually the storage server that offers the drive to the client will take care of that, but if it is really a local drive, everything always fails eventually. And what if you run out of disk space? It's not always easy to resize the drive, if at all. But nevertheless, block storage is a very common thing in Linux environments, and it will probably be so for a long time. Now let's go for a quick demo. So what we'll do is we'll list our block devices, create a file system on an available drive, and mount the file system to a mount point. So we use lsblock to list our block devices, and in the left column we see three drive letters SDA, B and C, which are three unpartitioned SCSI disks. And SDA obviously has a file system because it is mounted to /mnt/drive A. Now I create another mount point in MNT and call it drive C. Then I use mkfs to create a file system on SDC. So that's done. And I mount it to drive C. So now we can start working in the file system. As I mentioned, the client has full control. Now let's have a look at file level storage. File level storage, or file level access, is precisely what it says. The client operating system is no longer able to manage the blocks it writes, and let alone manage the device. The operating system needs helpers to access files, which are not local but remote. And these helpers are file level protocols like NFS and SMB, Network File System and Server Message Block. These protocols offer access to directories on another system, but offer no control whatsoever on the underlying file system that these files reside on. The client, and yes, all of a sudden the almighty operating system is just the client, has got no idea what it's actually accessing. It's a network protocol that offers access to the files. So the only thing it can manage is files and directories. Now a fantastic advantage is that many operating systems are able to use such an NFS or SMB environment. Of course, a lot of work will have to be done by the server that offers all of this beauty, but for the client system that needs it, it's a walk in the park. The client only manages files and directories. And as mentioned, the fact that the storage can be shared among many systems and access is very easy, these are two major advantages over block storage. Now let's do another quick demo. So I'm logged into the client again, and there's a server somewhere that shares its storage with me. So I check that whether it's true by using showmount, which is an NFS utility. And again, in /mnt I create a directory, and this time I call it server share. And now, instead of mounting a local file system, I simply mount a remote file system of which I have no further knowledge than its available space. And I can start working in that file system. Okay, so What's left is object-based storage. Well, that's a completely different beast. We can simply stop thinking in block devices and remote file systems and directories and all that stuff. In fact, we can forget about file systems altogether. We should start thinking HTTP, so web-based. So no files anymore, no underlying file systems, no local block devices, but objects. And very often with object-based storage, the cloud is mentioned. So not seldom it's referred to as cloud storage. But you can run your local object environment as well, as we will see in another video. But okay, object-based storage is very popular in cloud environments for data that does not have to be modified every couple of minutes and is kind of unstructured, like PDFs, MP3s, MP4s, complete movies you would like to stream, etc. Anyway, stuff you store in object storage is not something you want to edit at a regular basis and is at the heart unstructured. Basically what happens is a client has a file that it uploads. It will then be transformed into an object where the properties and the data are separated into metadata and data blocks. The metadata of these files, like its name and where the data blocks are stored and the size and things like that, are completely separate from one another. To be precise, in most cases the metadata of objects is stored in NoSQL databases and the data blocks themselves are stored somewhere else. So we cannot speak of file systems anymore, no way. So we could really think of it as cold storage, something you will write once and maybe read every now and then. In Linux there is something which is called MinIO, with which you can create something which is called an S3 bucket. Now S3 stands for Simple Storage Service, so 3 S's, and was made famous by Amazon Web Services. And on Linux we can run MinIO, which is S3 compatible. And again, in another video we'll address MinIO. So the major differences between object storage and the other two are that with object storage you do not edit objects. You simply don't. You download them and upload them. So for example, you create a video, you make sure you like the MP4 and then upload it. And if you want to change it, you first download the video again, modify it locally and upload it again as a completely new object. And finally, accessing a bucket is not via commands like copy, SCP, FTP or anything like that. What you use are HTTP calls like HTTP GET, HTTP PUT, HTTP LIST, etc. So yes, it is web-based access, so in fact it doesn't matter where I am, as long as I have internet. I can get to my objects at all time. Now let's go for a final quick demo. Now I'm logged into my client again, and there are multiple tools with which you can access your buckets. I usually use the command line tool, which is called AWS CLI. Well, it's beyond the scope now how to set this up, but all I really need is an access key and a secret key, which I have. And my buckets are somewhere in Ireland, and I can access them from my hometown in the Netherlands, as from anywhere else in the world, simply by listing them. And look at the contents like this. So I run AWS S3 ls and then the bucket name, for example S3 uadmin scripts. And if I want to upload a file, I create the file locally and then I upload it using the cp command. Hey, but that's not the Linux copy command. It will simply run an HTTP put. And removing the file will run an HTTP delete, masqueraded as RM. And we're done. Now in summary, with block storage the client is in full control of the device and the file systems on it. With file storage the client accesses a remote file system that can be shared by many others, and the client only manages files and directories. And with object storage we speak of objects, not files, and it's popular in cloud environments and ideal for unstructured and relatively static data. So, just under 10 minutes.